Today we are finding limits when we're given a table of values of a function. And we're also going to be finding limits of compositions of functions. So we need to be able to evaluate limits, determine limits, when we're given a variety of different kinds of information. Yesterday we did the graph of a function. Today we're going to be doing a table of values of a function. And then tomorrow we're going to be doing evaluating limits given the equation of a function. And then we will have a combination of all of those. So let's consider this function. We know back when we studied rational functions, we know that f has a vertical asymptote at x equals 3. I know that that's a vertical asymptote. So what does that mean the graph is looking like there? It means that at x is equal to 3, what is the function doing? It is going to either positive infinity or negative infinity on both sides, right? On both sides. That's what a rational function does at its vertical asymptotes, right? So what would a table of values look like if we were getting closer and closer to 3? We know right at 3 we should get nothing, right? Because when x is 3, it is undefined. Let's go ahead and put this into our calculator. I'm going to do a fraction so I can make it look just like I see it. So the quick way on most of your calculators, on the even a little bit newer calculator, the quick way you can get to the fraction template under F1, or if you do alpha x, it's a quick way, it's a shortcut to get to that fraction template, and that will work on most of your TI-84s. Okay, so I'm going to put x plus 5 over x minus 3, but I want for all of my answers to be decimals. So I'm going to change that 3 to 3.0. Okay, if you just put a decimal after that 3, or the 5, it doesn't matter which one, or both. Now our answers will be in decimals rather than fractions, and I'd rather have a decimal for what I'm doing. Okay, so we're going to complete this table. So I want to go to my home screen. Y1 at 2. What is y1 at 2? y1 at 2 is negative 7. What is y1 at, let's get closer. 2 is close to 3, but we can get closer, true? 2.9. Negative 79. Think about where that would be on the graph. 2.9 for x, negative 79 for y. 2.99. Negative 799. When x is 2.99, the value of the function is negative 799. What about 2.999? I could keep on doing alpha F4 to get to my y1, but you can also just scroll up, grab that, and then I'm just going to add another 9 to the end. Negative 7,999. What do you think would happen if I added another 9 to the back of that? It would be getting even closer to 3. We would be another magnitude higher or lower, right? So at 3, what's it going to give me? An error. It's a division by 0 error, right? Attempted calculation contains a division by 0, so the calculation failed. This is non-existent. Okay? What do you think would happen? So I now know as x approaches 3, on the left of 3, we are going to negative infinity. Does that tell me what's happening on the right of 3? Let's find out. On the right of 3. Okay. y1 at 4 is 9. What about 3.1? 3.1 is much closer to 3, right? Well, we're at 81. What about 3.01? If you want to insert a 0, see the little INS button? That's your insert button. Well, I accidentally hit delete, but you can insert a 0 there. 801. So at 3.01, we are at 801, right? I'm going to go insert another 0. At 3 point, gosh, I can't write. My golly Moses. At 3.001, we are at 8001. So what's happening as x approaches 3 from that side? Well, it's going to positive infinity, right? Yeah. So what is the limit as x approaches 3 from the left? From the left, it's going to negative infinity. From the right, it's going to positive infinity. The overall limit does not exist because even one of the one-sided limits was infinity or negative infinity. And remember, if even one of the one-sided limits is positive or negative infinity, then the overall limit does not exist. Let's consider this function. Let's go through the same process for this one. I'm going to come in and change my function to x squared minus 4 on top and x plus 2 on the bottom. And again, I want these to be decimal answers, so I'm just going to put a decimal point after that too. Okay. I'm going to go to my home screen and we're going to find out what happens. I know that right at -2, I'm going to have another division by 0 error. It's going to be undefined, but I will wait till I get there. Okay, y1 at -2.1 is -4.1. Okay, what about -2.01? It's getting closer to -2 on the left. -4.01. Interesting. Okay, what about putting another 0 inside there? So we're getting very close to -2, but on the left of -2. -4.001. What do you predict would happen if I put in -2.000000001? Even though it's not on my chart, what would that look like? Is that true? No, it's not true, but my calculator reached its tolerance error and it rounded. Okay? What happens if I put in just a -2? Division by 0 error does not exist. But what did this approach? What were we getting closer and closer and closer to? It was getting closer and closer and closer to -4. That limit is -4. Okay? Let's go on the other side. Let me get a different color here. So this told me, you guys, is there a vertical asymptote at x equals 2? using our knowledge of rational functions, is there? Clearly not, because we're not going to infinity, right? Clearly not. This is equal to x plus 2 times x minus 2 over x plus 2. We have a hole when x is equal to negative 2, right? I know there's a hole there. Okay? Alrighty. Let's go finish this table. Okay, I'm going to start on this other side. I'm going to put negative 1.9. So we're approaching negative 2, but on the right of negative 2. Negative 3.9. Negative 3.99. Negative 3.999. What are we getting closer to? We're getting closer to negative 4. Closer and closer and closer to negative 4. Which is not shocking, because I already know there's a hole there. And if there's a hole, the limit from the left must equal the limit from the right. The overall limit is negative 4. At x equals 2, we say that f has a hole. Since the limit from the left is equal to the limit from the right, but not equal to the value of the function. Okay? Another reminder, if even one-sided limit is positive or negative infinity, the overall limit does not exist. An overall limit can never be an infinity. Okay? Alrighty. Let's look at some multiple choice questions now. Alright. The table gives values of a function f at selected values of x. Which of the following conclusions is supported by the data in the table? And in each of these, we are approaching 9. I'm sorry, we're approaching negative 9. So where would negative 9 be in this table? Where would negative 9 be? Negative 9 would be right here, right? And I have no idea what the value of f when x is negative 9. I have no idea what it is, and I don't care, because a limit is only what we are approaching. On the left-hand side, it appears to be getting closer and closer and closer to 3. So this tells me that the limit as x approaches negative 9 on the left is 3. Okay, what are we approaching on the right? Well, on the right, it looks like it's approaching, it appears to approach 6. So the limit as x approaches negative 9 on the right-hand side, a little bit higher than negative 9, it appears to be 6. I'm mainly looking at this value right here for that, as I was mostly looking at that value there. Okay? So the overall limit is not 6 or 3, because these are not equal. The limit from the left is 3, the limit from the right is 6. That is answer choice D. Okay, let's do this one. Well, now we have F, G, and H. Okay. Which of the following conclusions is supported by the data in the table? I think this just froze here, you guys. Goodness, what happened? I'm going to pause and try to get it back. Okay, well, I'm having difficulties here. My screen just froze. I think I'm going to have to fiddle with this. So I'm going to end this video now, and then I'll start a new video in a second.